All right, good evening, fifth graders. Tomorrow we're going to be using a compass in math. A compass is a pretty fun material, or a pretty fun instrument we use in math. It's one of those things, and I'll be showing you a picture, but it's when you put the pencil on that little metal piece and it makes circles and you can make lines on it. Before we get started here, let's take a look at what a radius and what a diameter is. You might have seen this already in your math boxes a little bit. A radius, when we're looking at a circle, it's the middle of the circle to the outside. This is your radius, okay? Any line segment from the center of the circle to any point of the circle. The diameter is the straight line across. So as you can tell here, the radius is half of what the diameter is, okay? You're gonna be using that a little bit today. Here's a picture of your compass, okay? Don't worry, I have these in class. You'll be able to mess around with them a little bit in math tomorrow, and then we're gonna be using this to recreate triangles as we go. Here's your compass. So we're going to be drawing some small arcs and some circles with these. So you're going to be recreating some triangles. Let's keep on going here. Let's see what we have. Okay. What is the difference between a ruler and a straight edge? Tomorrow you're going to have to use a straight edge and not a ruler. Okay. Here's some differences. A ruler has a scale along at least one edge and is used to measure lengths, right? The numbers tell you how many centimeters, how many inches something is. A straight edge is a tool for drawing straight lines, but it is not used for measuring. So maybe at the side of a book, or you can use the side of a notebook or a clipboard. A ruler can be used as a straight edge even when you're not using it to measure something. See, a ruler could still be a straight edge as long as you're not using the numbers on it. And tomorrow you're going to be doing some practice with this. This page is a simple example of it. I'll be explaining more in class because you don't have a protractor at home. The main focus of tonight's video is to explain this. Vertical or opposite angles, and then we have adjacent angles. You have to keep in mind, a vertical and opposite angle are the same exact thing. So this is one type of angle we're working with today. Then an adjacent angle is another type of angle we're working with today. Okay? I gave them some names, okay? So when two lines intersect, the measure of the angles opposite each other are called vertical angles. I call them Vicky. Vicky helps me remember because Vicky starts with a V, and V and vertical. I don't know. That's just how I've been able to remember them in the past. Hopefully you might come up with your own idea here. So if this is a vertical angle or opposite, if this angle right here is 40, the one straight across has to be 40 as well. Okay? That's what vertical angles means. They're right across from each other. So Vicky or opposite angles are right across from each other. The next one here, angles that are next to each other and have a common side are called adjacent angles. I call these addy angles. Okay? Addy angles are right next to each other. They live right by each other. These are addy angles. When you add up addy angles, as you can see right there, it would equal 180 if they make a straight line. Okay? So addy angles are right next to each other. Vertical angles are opposite each other. So Vicky angles are across from each other. Addy angles are right next to each other. So if I have a neighborhood here, okay, I've got two lines that are intersect. And what I want you to keep in mind with this, if I have a road or a street right here, this side of the street, if I add up this angle and this angle, equals 180, right? Because this is a straight line that goes right in the middle. The same thing the other direction. Here's a straight line that goes. So this angle and this angle, when you add them together, equals 180. It's the reason why I showed this picture. It helps out a little bit, okay? Erase this. So, if this is Vicky's house, an opposite or vertical angle to Vicky would be straight across the road right here. This is another Vicky house, okay? Now, let's say Addie, let me erase Vicky's house here, just so we're not confused. Addie, or an adjacent angle, let's say lives in this house, okay? Addie can have two neighbors that work out, okay? Addie could have a neighbor right here, which would make an adjacent angle, right? Because I'm dealing with this straight line. This is an adjacent angle to this because they're right next to each other. Addie could also have this house be a neighbor because of this straight line. The only house that is not adjacent to Addie's house that I circled previously is the one that is directly across. This is not an adjacent angle. This would be considered a vertical angle because it's directly across. Try to provide another example here. Seems easy, but for some reason kids kind of get confused with this as we go here. So I'm going to put some numbers in here so we're not just looking at houses. Let's say this is 60 degrees. Okay. That angle right there is 60 degrees. I want to know the vertical or opposite angle of this, and that would be directly across the streets. Right here would be my vertical angle, so this would have to equal 60. Now with that being said, what are some adjacent angles to that 60? Well, this right here would be adjacent. This right here would be adjacent. So 60 plus what number equals 180, right? It would be 120. So this is 120. As you can see now, got a straight line, right? 60 plus 120 is 180. This would be 120. 60 plus 120 is 180. Hopefully that helped a little bit. So remember, vertical or opposite angles, which are Vicky angles, are directly across from each other. Adjacent angles or Addie angles are right next to each other. Okay, hopefully this helped a little bit. I know it's a short video. Look forward to working with some compasses with you in class tomorrow.